In section 1-7, you're going to write functions using function notation and evaluate and graph function notation. So let's just review here that whenever you use the word function, it automatically means you're talking about a relation, which is a set of ordered pairs that can pass the vertical line test. So it can pass the vertical, and then we're just going to put in line test. So that means it has no x values that repeat. This is an example of function notation. Now you may have seen that before in Algebra 1. Quite often you'll see this first. This is not function notation. Function notation has f of x or g of x. Also want to identify dependent and independent variables. Those are important. Dependent variable is the output value. So that would be the y. This would be dependent here. Its value depends on the value of x. So that's one way you can kind of remember dependent versus independent. The independent variable is the input value, or x. So dependent refers to y, independent refers to x. Discrete functions, we're going to graph a discrete function, and that is just a function whose graph consists of points that are not connected. So that is a discrete function. We're going to also be writing a function rule, and that is just an algebraic expression that defines a function. All right, let's look at function notation. I'm going to give you an example of just an equation here. If we say y equals 3x plus 2 and we let x equals 2, what's the difference that you see between those two writings, here and here? Well, hopefully you see that the difference between the equation above and the function notation at the right is just that the only difference is here we're using y and here we're using f of x. Now, I do want to point out that this is not f times x. It simply means the value of the function that's called f for the value x. So instead of saying let x equal 2 like we did here, you would know what to do. You would say, okay, well, I'll plug the 2 in for x and then I'll find y. Instead of saying that, in function notation, we can just say f of 2. So x is replaced with the value 2 on the left side of the equation. So it has to be replaced with 2 on the right side of the equation. All right, let's do some examples here. And you might say, well, why do you have to use f of x? Well, that allows us to list several different functions. And if I want to, so here I have on the left-hand side, I have 3 different functions. If I say find g of 3, that means I'm going to look over here, find the function that is called g, and I'm going to substitute 3 in wherever I see an x. So g of x is 2x minus 1. So I'm replacing the x with 3 here. I have to replace the x with 3 here. So that's 2x minus 1, or 2 times 3 minus 1, which would give us 6 minus 1. So the final way that you would write it is you would say, okay, I'm taking the function g, I'm substituting in 3, and the value that I get is 5. So my input value is 3, my output value is 5. Let's do another function. This time let's use the function h, so that identifies that I need to go to this function here. This time I'm going to substitute 5. So that means I have negative 2 times 5 plus 6. And when I go to simplify that, I get negative 10 plus 6. So for the function h, when I substitute 5 for x, I end up with the value negative 4. So again, this is my x value, my input, and that's my y value, which is my output. Now, you can evaluate a function from a graph, and this is actually pretty easy. Sometimes students have trouble with it just because they have difficulty reading it, but it's very, very simple. To evaluate a function from a graph, find the indicated x value on the graph and list the corresponding y. So let's look over here. If we want f of negative 2, that means when x is negative 2, what is y? If I go over here to negative 2 for x, I just trace it up until I find the y value. Well, when x, this point right here, on the function is at -2, 2. So then we just say when the function has an x value of -2, the y value is 2, ordered pair is -2, 2. F of 0, well, let's go find x where x equals 0 right here. If I were to write that ordered pair, it would be 0, 0. So f of 0 equals 0, gives me an ordered pair of 0, 0. F of 3, 1, 2, 3, go over here. I need to find a point that has an x value of 3, and when I trace it down here, this point does. I list the x value, which is 3, y value, which is -3. So f of 3 equals -3, or 3, -3 is the ordered pair. Okay, talking about dependent and independent variables, sorry. In order to find the value of g of x, we need to know the value of x. So in other words, the value of g of x depends, notice I bolded and underlined that, on x. So g of x depends, so it's dependent. Changing the value of x changes the value of g of x. So x is the independent variable, and g of x, or you can think of that as being y, is the dependent variable. So let's look at a discrete function on the left side here. A discrete function is when we do not connect the points. And a discrete function can be represented by a mapping. So I'm going to ask you the question, can we find the value of y when x is 4? Well, if we look up here, we don't have a 4 listed, so we don't know what the y, or in the x mapping here, so we don't know what the value for y would be. So no, we can't find the value. So we are not going to connect the points. And this graph is a little small actually for these values, but we're just going to graph them off to the side here. So we'll graph 3, 2, and then 5, 6, and then 7. We'll go off a little bit here up to 10, just kind of estimate where that would be, and then 9, 10. These are not connected because we don't have a point x value of 4, we don't have an x value of 6 or 8. All right, now this, so discrete, the points are not connected. This would represent a continuous function. F of x equals x, and we'll just put the 1 right here. It kind of went down to the other line here. Didn't have enough room. So if I want to find f of -2, I'm going to substitute a -2 because I replaced the x. Here's the x. Now it's replaced with -2, so replace it with -2 here. That's going to give me a -1. So my ordered pair is going to be -2, -1. Now I'm going to replace the x with 0, so it would be 0 plus 1, or 1. Ordered pair is 0, 1. Again, third point, I'm going to replace the x with 3, and that's going to be 3 plus 1, or 4. So I have the ordered pairs -2, -1, 0, 1, and 3, 4. Now I'm going to ask you the question, can you find f of 4? If I were to substitute 4 here and 4 here, could I get a value for y? And the answer is yes. So since we can find any value here, those points are going to be connected. So we're going to draw a line through, oops, let me use this here. We're going to draw a line through those points. And that's a continuous function. We'll connect the points. All right, writing a function rule. To identify the function rule, you first identify the independent variable, which is x, and the dependent variable, which is y. So as we read this, Carnival charges $5 entrance fee. I just put a box around that. That's one piece of information. $2 per ride. That's another piece of information. So we want to write a rule that represents the total cost after you've taken a certain number of rides. Okay, so ask yourself, does the cost depend on the number of rides, or do the number of rides depend on the cost? Well, the cost depends on how many rides you take, because they're $2 per ride. So how many times do you have to pay the entrance fee? Well, you're paying the entrance fee one time. And then if we go on 2 rides, let's just figure out mathematically what that would look like before we try to write the rule. We'd have a one-time fee, $5, and we're writing 2 rides, and they're $2 each, so we would just say $5 and then 2 times 2. If we want to do 6 rides, we would still have to pay the $5, and we would have to do 6 number of rides times $2 and add those together. So that gives us an idea of what our rule should look like. We know that $5 is a one-time fee, and it's $2 per ride. So that can lead us to the function rule, f of r, where r represents the number of rides, is $2 for each ride, and then we add the $5. So if we want to find the cost for 4 rides, we have f of 4. We're just going to replace the number of rides with 4, and that would be 2 times 4 plus 5. Okay, so you have some questions to do on the next page.